Our next configuration section is actually going to be about rapid spanning tree. But to really understand rapid spanning tree, we first need to understand spanning tree. So let's take a look. We have two QFX switches. This time they are QFX2 and QFX3, and they are connected by interface XE002. User A is connected to QFX switch 2 and user B is connected to QFX switch 3. Now, having a single link isn't something that we want from a design point of view, as it introduces a single point of failure. So we're going to add an additional link, XE003, for redundancy. However, introducing an additional link also introduces an additional problem. User A is going to send a frame to QFX switch 1 looking for user B's MAC address. This is an ARP request, which is also a broadcast frame. The switch receives the frame, and because it doesn't have an entry in its bridge table, it will send the frame out of all of its interfaces, except the link where the frame was received. This means the frame will be sent out XE002 and XE003. When QFX switch 3 receives the frame, it will also send the frame out of all of its interfaces. And this is where the problem lies. The frame received on interface XE002 will be sent out XE001 and XE003 back to QFX switch 2, and the frame received on interface XE003 will be sent out XE001 and XE002, also sending it back to QFX switch 2. And as simple as that, we've got a loop. And because Ethernet frames don't have a time to live, this is going to happen indefinitely. It's just going to keep looping back and forth, back and forth.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
But have no fear, STP is here. This is only used when there are redundant paths through a layer 2 network. Spanning tree prevents loops and calculates the best path through the network. So let's revisit our diagram. QFX2 and 3 have been joined by QFX1, and these three switches are all interconnected with the appropriate interfaces. User A connects to QFX2, whereas user B connects to QFX3. And the fact that we have three switches interconnected means that we have redundant paths throughout our network. Sounds like an ideal case for spanning tree. Spanning tree first needs to elect a root bridge, as all the non-root switches find the shortest path to the root bridge. The way that a root bridge is elected is by the lowest bridge identifier. This consists of the lowest priority and the lowest MAC address. So let's take a look back at our diagram. We can see that the priorities are the same, so next we can take a look at the MAC address. The MAC address of QFX1 is the lowest, so this will become the root bridge for our spanning tree network. And QFX switch 2's shortest path to the root bridge is through interface XE002, and this will be called the root port. And the same goes for QFX switch 3. All ports on the root bridge itself are forwarding ports, and these are called designated ports. We also need to stop the potential of a loop, and because both QFX switch 2 and QFX switch 3 need a link to the root bridge, then we need to block one of the ports between these two switches. Again, it will be the switch with the lowest bridge identifier. The priorities are the same, but QFX switch 2 has the lower MAC address, so QFX switch 3's interface will be blocked, and this block port is called a non-designated port. Okay, finally, after all of this, we can get to see which path a frame will take through our spanning tree network. User A sends the frame to QFX2, which sends it up to the root bridge, which is QFX1. All these ports on QFX1 are forwarding, so QFX1 is going to forward the frame onto QFX3 and then onto user B. There's a burning question here though. Does all traffic have to pass through the root bridge? Well, actually no. The root bridge is just a reference point in the network. Traffic will take the shortest path in the spanning tree topology as long as it doesn't cross a port that is being blocked. Now we get to the crux of the matter. What's the difference between STP 802.1d and RSTP 802.1w? Now with STP there are 5 port states. These are disabled, which is the result of an administrative command that will disable the port. Then you have blocking. When a device is connected, the port will first enter the blocking state. Then you have listening. The switch will listen for and send BPDUs. However, no data is sent in this state for 15 seconds, just to make sure there isn't a topology change. Then you have the learning state. If the switch receives a superior BPDU, this is a BPDU that has a lower bridge ID, the switch will stop sending its own BPDUs and will relay the superior BPDUs. This also takes 15 seconds. Finally, you have the forwarding state, where the port is forwarding traffic. And then there can be an additional 20 seconds before all the BPDU information is saved. That's 30 to 50 seconds for normal spanning tree to reconverge upon a topology change, which isn't quick at all. Rapid spanning tree merges the first three states of spanning tree. So disabled, blocking, and listening are merged into one state, which is called discarding. So we would say that there are three rapid spanning tree states, with the first one being discarding. When a device is connected, the port will first enter the discarding state. Then you have the learning state. If the switch receives a superior BPDU, this is a BPDU that has a lower bridge ID, the switch will stop sending its own BPDUs and will relay the superior BPDUs. Then you have the forwarding state. This is when the port is forwarding traffic. However, the main reason that rapid spanning tree is able to transition so quickly is because it isn't timer based. RSTB confirms that a port is able to transition to the forwarding state without relying on any timers. It does this by first using the edge port. With the edge port, all ports directly connected to end devices cannot create bridging loops, so there's no need for the listening and learning states, and they can transition to forwarding immediately. Next up is the link type. A port that operates in full duplex is thought to be a point-to-point link. And although most links, even on shared media networks, run in full duplex mode, these links are considered to be point-to-point by RSTB and are eligible to be rapidly transitioned to the forwarding state.
It's question time. Question 1. What type of frame is an ARP, Address Resolution Protocol, request? A. Multicast frame. B. Broadcast frame. C. Unicast frame. D. Collision frame. The answer is B. An ARP request is a broadcast frame. When a device needs to determine the MAC address associated with a specific IP address, it sends an ARP request as a broadcast frame to all devices on the local network. This broadcast ensures that the device with the matching IP address will receive the ARP request and respond with its MAC address. Question 2. What is the purpose of Spanning Tree Protocol, STP, in a network? A. To prioritize and forward specific types of traffic based on quality of service, QoS, settings. B. To enhance network security by filtering and blocking certain types of frames. C. To facilitate automatic IP address assignment within a subnet. D. To prevent and eliminate loops in Ethernet networks by blocking redundant paths. The answer is D. The primary purpose of the Spanning Tree Protocol, STP, is to prevent and eliminate loops in Ethernet networks. STP achieves this by dynamically selecting and blocking redundant paths, ensuring there is only one active path between any two network devices. Question 3. What is the purpose of the Spanning Tree Protocol, STP, root bridge in a network? A. It serves as a reference point for the STP topology and provides a central point of control for loop prevention. B. It prioritizes and forwards specific types of traffic based on quality of service, QoS, settings. C. It acts as a security gateway, filtering and blocking certain types of frames within the network. D. It facilitates automatic IP address assignment within a subnet. The answer is A. The purpose of the STP root bridge is to serve as a reference point for the STP topology and provide a central point of control for loop prevention. The root bridge is elected based on the bridge ID, combination of priority and MAC address, and it becomes the focal point from which STP calculates the shortest path to each switch in the network. To get the complete question banks for all the jncis-ent videos, drop us an email at info@rittercoach.com.